has. In math, the opposite is the negative. If it was -5 as a velocity, it's going to become +5. If it was +8, it's going to become -8. It's just going to be the opposite sign. A negative velocity is moving towards the left. A positive velocity is moving towards the right. Putting a negative in front of a negative makes it positive, and putting a negative in front of a positive makes it negative, makes it the opposite. Think of the negative as the opposite guy. Self.vx. I'm going to do the same thing with the y, and then we'll see what that looks like. Self y is greater than the height of the screen. Self vy is negative self vy. Let's see what that looks like. And we might want to speed this guy up a little bit. He's moving really slowly right now, so let's just speed him up. Instead of 0.3 and 0.1, I'm going to make him 3 and 1, 10 times faster. And stop and run. All right, so what happens when he hits the edge? It's hard to see, it's kind of small. Let's make it a bit bigger. Rerun that. When he hits the edge, so he goes off. Goes off at the bottom as well, and then comes back up to some for a second. But then he goes way off on the left-hand side of the screen. He goes totally off the screen. We need to fix that in our Viking class. He bounces too late. I want to make him bounce earlier. I'm going to subtract his width, self.w. Width, take away the width of the Viking, and the height, take away the height of the Viking, so self.h. But I also want to copy this for what happens if it goes off on the left-hand side of the screen. What happens if the x is less than 0? Just a quick word about the less than, greater than, in case you haven't worked with those a lot. Less than, greater than, it's really the same symbol. It's just the symbol's always eating the bigger number, right? You think of it as a little crocodile, and it's always eating whichever number's bigger. 5 is greater than 2. You would have, like, that would be written like 5 bigger than 2. So the crocodile's eating the 5, right? It's always eating the bigger number. Think of it that way. If x is less than 0, then we'll switch the direction. And we'll do the same thing for the y as well. If the y is less than 0, we'll switch its direction. If the y is less than 0, then our vy is going to be the opposite of vy, and stop and run. Okay, let's see what happens. When it hits it, bounced perfectly. Does it bounce off of this side? Perfectly. There we go. There's our bouncing code. And there's our Viking. Last thing to do. This is a Viking object, and it's moving around. To illustrate what an object can really do is if we make more than one. I'm going to make something called an array in my Viking, in my main program. The main program, an array of Vikings. So I'm going to call these guys my Vikings is equal to a new array. So just open square bracket, close square bracket. A variable can hold something. Like a variable, you think of it as like a cardboard box, and you can put something in it. An array is more like an egg carton, where it can hold many things. So I'm going to hold many Vikings. I'm going to make a little for loop. So for n in range, so n is some number in a range, and we're going to go to, I don't know, let's make 5 Vikings. Then I put my colon, and anything after this will be indented. So I'm going to put my Viking right there. Then I'm going to tab my Vikings dot append my Viking. All these Vikings are going to be identical. They're all going to be at 200, 200, moving with the same velocity, 3, 1. I want to be able to make up new Vikings. To do this, I need something that's going to make a random number. I'm going to make a little function, def. I'm going to call it myrand, and it's going to take 3 arguments, a, b, and c. The a is going to be like, let's say you wanted to pick a number between 5 and 10, but you don't want it to be 7. The reason for this little like, but I don't want it to be this, is when you're picking velocities for your sprite, you want it to be between -5 and +5. You just don't want it to be 0. So that's why the c is important. I'm going to make a variable called rand, R-A-N-D, is equal to our c value. And then I'm going to say while rand is equal to c. You need the 2 equals here, because a single equal assigns a value. Like rand equals c is we're saying that the rand is the same as the c value. But what I'm doing here is I'm saying while the rand is the same as c, we're checking to see is it equal. So while rand equals c, we are going to pick a new rand. Rand is equal to random dot rand range. So this function called random dot rand range just picks a random number between a certain range, between a and b, between a and b, and we're going to go up by 1. That's what the rand range does. We have a random number, rand, and we've just made sure that it's not equal to c. If it picks 1 and it's equal to c, it just keeps picking until it's not equal to c. Once it's not equal to c, we're done.